Assalamu alaikum everyone. So today we are going to do ATP O levels 5070 paper 41 October November 2024. Let's start with question number 1. A teacher investigates the electrolysis of molten lead to bromide. Lead to bromide is solid at room temperature. Figure 1.1 shows the apparatus the teacher uses. Okay, so here you can see, and as it's a molten, it's a solid at room temperature, so that's why we are need to continuously heat it to keep it in a molten state, so the electrolysis can occur. Okay. Name the piece of apparatus labeled L and M. Suggest the material from which L and M are made. So first you have to tell their name. So L and M are
Electrodes.
yes, electrodes. Very good, Mirar. Electrodes. Now you have to name the material. So usually when we are doing the molten electrolysis, we are using the inert electrode, and the inert electrodes are made from yes,
Platinum.
platinum. Very good, Nabiha. Usually it can be made from platinum or it can be made from graphite, which is of carbon. So either you can write platinum, that can be considered as correct. And beside platinum, you can either write graphite, which is carbon. Okay. So see, the question number first is from electrolysis. Now, next part. Describe the appearances of the products at L and M. So if you see at L, L is a negatively charged electrode. So it means L is going to attract the positively charged ions, which are lead. And when the lead gain electron on the L, it turns into a lead metal. Okay. And usually due to the high temperature we have discussed earlier in the electrolysis that they appeared as a molten. Okay. Now on M, as its M is positively charged, so the negative ion are going to be attracted towards the M electrode, and when they loses their electron and turn into elements. So bromine as an element diatomic, so we need two bromide ions and two electrons are lost. I hope it's clear to all of you. So by looking at the equations, and due to the high temperature, bromine is liquid at room temperature, but due to the high temperature, it forms as a gas. So can anyone tell me what will be the appearances of the products at how lead looks like? What is the color of lead?
Gray. Silvery gray.
Silvery gray. And as I have told you, that due to the high temperature, it is going to be a liquid and it is going to be deposit over there. So, okay, there is no need to write. Okay, appearance of M. So what is the color of bromine?
Brown.
Brown. And as it's forming a gas, so we are going to observe a brown vapors. Is this understandable to all of you?
So shouldn't L be a solid because it's going to be deposited on the electrode?
Yes, but if you recall, we are doing the electrolysis of a molten, and for a molten, we need to heat it, right?
Yes.
So it means we need to continuously heat the container to keep the lead bromide molten for the whole process, isn't it?
Yes.
So it means there is a very high temperature to be maintained, isn't it?
Yes.
So due to that high temperature, usually the lead forms over here or the metal forms over here is going to be in the liquid form. So it is as it's a metal, so it is a thick liquid because metal is very dense. So, but sometimes examiner do accept solid, but in actually it a silvery gray liquid appears.
So sir, when will a solid form?
When we are doing the aqueous electrolysis, because the electrolyte is dissolved in water, and when it is dissolved in water, we have it becomes like liquid in the aqueous state in the at the room temperature. So when at the room temperature the metal forms as a solid.
Okay.
Is this clear?
Yes.
Okay. Now, so I hope till here it's clear. Now C part. The teacher stops heating and allows the lead bromide to cool. Explain why the lamp goes out. So as it stops heating, the lead bromide allows to cool. So on cooling, it solidifies, right? Right? The lead bromide to bromide solidifies or
Yes,
turns solid. So as it turns solid, the ions stop moving. And as the ions stop moving, what is going to happen to the current? Current stop flowing, or current stops flow. So as current stops flow, the light goes off. Is this clear? Yes, is it clear to all of you?
yes.
Okay.
Yes.
Now, question number 2. A student titrates 4 sample of 0.8 mole per dm cube aqueous sodium hydroxide with
Sir, sorry,
aqueous
can you show part C again?
ethane
I
dioic
just
acid.
forgot to mention.
Yes, yes.
Okay, thank you, sir. Okay.
Okay. So a student titrates 4 sample of 0.8 mole per dm cube sodium hydroxide with ethane dioic acid. In titration 1, the student rinses and fills a burette with aqueous ethane dioic acid. So see, they are taking acid in the burette. Uses a volumetric pipette to add 25 centimeter cube of sodium hydroxide to a conical flask. Add thymolphthalein indicator to the conical flask. Okay, we have added sodium hydroxide to the conical flask, and then we are adding thymolphthalein. Can anyone recall what is the color of the solution now? What is the color of the thymolphthalein in the alkali?
Blue.
Blue. So sodium hydroxide is a alkali, and we have added in the conical flask, and then we are adding the thymolphthalein in it. So the color goes blue. Now, places the conical flask on the white tile. Add aqueous ethane dioic acid from the burette while swirling the flask, adding drop by drop near the end point until the solution stop just changes the color. So see, they have explained you the whole method of titration, that from the burette we are going to add ethane dioic acid, and then we are going to add it drop by drop at the end point, and when as the drop goes inside the conical flask and it changes the color, we stop adding further ethane dioic acid to it. Is this understandable to all of you? The student repeats the titration 3 more times. Okay. Figure 2.1 shows the burette reading for 2 of the titrations. Okay. Record the burette readings in the table 2.1, complete table 2.1. Okay. So if we go here, it is 0.2, it is 21.1, it is 21.3, it is 41.8. Is this clear? So now we are going to fill it. So titration 1, final reading is 21.1. Initial reading is 0.2. Then in titration 2, final reading is 41.8. Initial reading is 21.3. Now, when we subtract it, we will get the volume of ethanoic acid used. So in the first case, can anyone subtract it and tell me the answers, please? So is it 20.9?
Yes, sir.
20.5? And as if its
Yes.
final is 20 and the volume used is 20.1, both are the same. So it means the initial reading is 0. So you don't just write 0, you just write 0.0. Do remember this. Okay. Then
19.9.
19.9. Okay. Now take the two best titration results in table 2.1. So the best one are the one which have a smallest difference. So if you see the smallest differences between 20.1 and 19.9, they are closest to each other, right? Now,
Yes, sir.
Sir, can
see
you explain that again? I don't understand it.
that the part where I take the two titrations.
Yes.
Okay. See, look at the four results. You are going to take those two which are closest to each other. So see the difference between these two. Isn't it 0.4?
Yes, sir, I got it now.
Okay, 0.3, 0.2, and C. If you take this and this, or this and this. So the closest is these two, right?
Yes.
Okay. Now, C part, use the tick titration results in table 2.1. Calculate the average volume of the aqueous ethane dioic acid needed to neutralize 25 centimeter cube of aqueous sodium hydroxide. So, for the average volume, the two values which you ticked, you are going to take those two and then you are going to divide it with the 2. So on dividing with 2, what we will get? We will get 20.0. So the average volume is 20.0. Now, what they are asking next part, calculate the number of moles of sodium hydroxide in 25 centimeter cube of 0.8 mole per dm cube NaOH. Okay. So if you see over here, they have given you the volume, they have given you the concentration. So we just directly produce the formula of moles, that moles of sodium hydroxide is going to be its concentration times its volume, which must be in decimeter cube. So either you multiply with 25 and divide by 1000 or just divide directly with, or just multiply directly with 0.025. Can anyone tell me the value, please?
0.02.
0.02. So we got the number of moles that are 0.02 of sodium hydroxide. Now see, sometimes they do give you the equation, and if you see over here, they haven't give you the equation. Instead of this, they have informed you that 1 mole of ethane dioic acid neutralizes 2 moles of sodium hydroxide. So see, you got the ratio of their mole, that when you react ethane dioic acid with sodium hydroxide, the ratio is 1:2. Now what they are saying next, use your answer to C and D to calculate the concentration in mole per dm cube of ethane dioic acid. Okay, from C we get the volume of ethane dioic acid. That volume of ethane dioic acid is 20. And to calculate the concentration, we need the moles, right? We know the moles of sodium hydroxide, which is 0.02. So for 0.02 moles of sodium hydroxide, we need X moles of ethane dioic acid. So if we go for the calculation of X, so X is going to be 1 multiplied by 0.02 over 2. It will gives you 0.01 moles of ethane dioic acid. You got the moles, you have the volume. Now you can easily calculate the concentration by dividing the moles with the volume. Volume is in centimeter cube, so you are going to divide with 1000 to turn into dm cube. On dividing with 1000, it is going to be 0.02 dm cube. So you just divide it with the 0.02 dm cube, you will get the answer. Can anyone tell me the value, please?
0.5.
Sorry,
0.5.
0.5 mole per dm cube. So we got the concentration, that it is 0.5. This after 5 there is no number, Yusra?
No, sir, 5 exactly.
Okay, now see over here. They ask you to write your answer in the three significant figures. So for three significant figures, you have to put two more zeros. So it is going to, you must write 0.500 in this case if you are not getting any other value after 0.5. Is this clear?
Yes.
Okay. Now, okay. Part F. The formula of ethane dioic acid is C2H4, C2H2O4.NH2O. 100 centimeter cube of aqueous ethane dioic acid contains 6.3 grams of this whole thing. Okay. Use your answer to E to calculate the relative MR of hydrated ethane dioic acid. Okay. So if you see in E, we got the concentration. What does concentration means? That these are the moles in 1 dm cube, right? It means these are the moles in 1000 centimeter cube. Is this understandable? That 0.500 moles are in 1000 centimeter cube. Is this clear?
Yes.
See, this means mole in 1 dm cube. And we know that 1 dm cube is 1000 centimeter cube. So if we know this, that 1000 centimeter cube has these much moles. So if there is 100 centimeter cube, then we get the moles, that how much moles were there in the 100 centimeter cube. So if we calculate the value, so it is going to be 0.500 multiplied by 100 over 1000. So isn't it 0.05 moles in 100 centimeter cube? Till here, is this clear?
Yes, sir.
Yes.
Okay. So see, these are the moles in 100 centimeter cube, right? These are the moles in 100 centimeter cube. And if you see over here, these are the grams in 100 centimeter cube. So it means that 0.05 mole is 6.3 grams, isn't it? So if this is the case, then we can calculate the MR, that mole is equals to mass upon MR. So MR is equals to moles upon, sorry, moles is equals to mass upon MR. So MR is equals to mass upon mole. So mass is 6.3 and moles are 0.05. When you divide this, you will get the MR. Can anyone tell me the answer, please?
Sir, I'm getting 126.
We are getting 126.
126.
126. So MR is 126. Is this clear to all of you?
Yes, sir.
Yes, sir.
Okay. Now, use your answer from F1 to deduce the value of N in C2H2O4.NH2O. Give your answer to the nearest whole number. So see, 126 is the MR of this whole thing. So can't I calculate the MR of just ethane dioic acid with without water, that is C2H2O4. So if I go for this, so it is going to be 24 because two carbons, two for two hydrogen, and 16 times 2, 4 is 48. Oh, sorry, 16 times 4 is 64. So 24, 26, 26 and 4, 30, 30 and 60. So it is going to be 90, isn't it? So 90 is the
Yes.
MR of C2H2O4. So from this, I am able to calculate the mass of water. That mass of water is going to be, because the above MR has a water in it and the below MR that I have calculated in this part doesn't have water in it. So when I subtract these two, I'm going to get the mass of
36.
water, 36. So the N is the moles, moles is equals to mass upon MR. So 36 is the mass of water, MR of water is 18. 36 divided by 2. So we will get the value of N, that is 2. Is this clear?
Yes, sir.
Any confusion?
No.
Now, G part. State why the conical flask is placed on a white tile before aqueous ethane dioic acid is added from the burette. Yes. So
To
it
see the color
because
change more clearly.
the very good Abdullah, because the white tile makes the color very clear, and when the color gets changed, that change would be very clear as well. So the color change can be seen more clearly. Now, each part. State why a measuring cylinder is not used to measure 25 centimeter cubes of sodium hydroxide in this experiment. So measuring cylinder is not accurate. That's what we have discussed earlier, and in that titration, we always need the accurate measurements. Measuring cylinder is not accurate. Is this clear to all of you?
Yes, sir.
Okay. Now, question number 3. A student investigates solid Y and solution Z. Solid Y is a white powder. The test the student does on Y are shown in table 3.1. Some of the observations for these tests are also shown. Okay. In test 1, excess dilute acid to Y in a boiling tube, the gas produced is tested using lime water. Colorless solution is formed and the gas forms lime water milky. So if the gas is forming, which is turning the lime water milky,
Carbon
means that
dioxide.
carbon dioxide. And if this is the carbon dioxide, then which ion is present in Y?
Carbonate.
Carbonate.
Carbonate
Very
ion.
good. So it means carbonate ion is there. Now, test 2, add dilute nitric acid to some of the solutions from the test 1. Add then barium nitrate, white precipitates are formed. So if you don't remember, don't worry, you have over here. So if you see dilute nitric acid and adding barium nitrate, you are getting white precipitate if the solution contains sulfate ion. So we know that it means there is a sulfate ion. Is this clear to all of you? So from the second test observation, it helps us to figure out that it contains a sulfate ion in it. So carbonate is present, sulfate is present. Now, test 3. Add aqueous sodium hydroxide drop by drop to the sum of the solution from test 1 until a change is seen and a change is white precipitate. So over here, initially, when we get the white precipitate with the sodium hydroxide, it means it can be calcium ion, it can be aluminium ion, or it can be zinc ion. Now, add excess aqueous sodium hydroxide soluble in excess, giving a colorless solution. So from this, that calcium ion can be excluded. If we got this observation, then it means either it is aluminium ion or zinc ion. Is this clear?
Yes, sir.
Is it clear to all of you?
Yes, sir.
Okay. Now, test 4. Add some aqueous ammonia drop by drop to some of the solution from test 1 until a change is seen. We are getting white precipitate. Add excess aqueous ammonia soluble in excess, giving a colorless solution. If we got this with the aqueous ammonia, so it means aluminium is not there now, but zinc ion is present. So see, if you don't remember this, again, you can take the help over here. You see, we are adding aqueous sodium hydroxide, white precipitate, white precipitate, white precipitate. See, insoluble in excess, soluble in excess giving colorless solution, soluble in excess giving colorless solution. So see, we don't get the insoluble, we get the soluble one. So we have excluded the calcium and we have concluded that we have either aluminum or zinc. Then we added aqueous ammonia in another test tube. See, white precipitates, white precipitate. Insoluble in excess. So see, again in aqueous ammonia, they dissolves. They get dissolved in excess ammonia, giving a colorless solution. So from this, we have concluded that aluminium is also excluded and we are left with the zinc ion. So there is a zinc ion present in the solution. Is this clear to all of you?
Yes, sir.
So we have identified the positive ion, which is a zinc ion, and the negative ions which are present are sulfate and carbonate. Now let's move to the next part. Describe how the gas is passed. Describe how the gas is passed through the lime water in test tube 1. You may draw a label diagram to help the answer the question. Okay, it's for 1 mark. So how we pass it? We bubble the gas through the lime water solution. Okay, and how we bubble it? We by the help of delivery tube, which is dipped in the lime water. So either if they ask you to draw the diagram, so you can draw this by showing like this. You make a test tube. Over here, you show the delivery tube. And delivery tube, and over here you put a bung so no gas can move. And over here you, so, okay. And over here, you will label it lime water. Here you will label it Y with what we have added in Y. We have added a nitric acid in Y. So you label this from this. Okay. With the Y and nitric acid. So see, this is how you can show it. And if you need to write it, you will write it. Use delivery tube and bubble the gas into the lime water solution. Now next part. Describe 2 other observations the student makes in test 1. So if the gas is being formed, right, they haven't mentioned beside this the gas. They just said the gas produced. So if the gas is being produced, you are going to observe a bubbles. And the solid Y, it is going to be disappear or dissolve. So solid disappears. And over here, you are going to write bubbles. Is this clear to all of you?
Yes, sir.
Sir, why
Okay.
would the solid disappear?
Because the solid is Y and Y is undergoing the reaction forming the salt, water and carbon dioxide. So eventually there is no solid because all have been reacted to form the products, right?
Okay.
Now, identify the gas produced in test 1. So we have already identified that it's carbon dioxide. They have used the term identified. They don't ask you to write the name or the formula. So you can write either name or formula, both are correct. Okay. Next, Y contains 1 anion. Use the observation from test 1 to identify this anion. So From the one where we get the carbon dioxide, we have identified that it's a carbonate ion from the test one, isn't it? Now, part 5, use the observations from test 2 to identify the dilute acid used in test 1. So we are getting the white precipitate and we have identified that there is a sulfate ion. So it means that that sulfate ion must come from the dilute acid, and that dilute acid is sulfuric acid H2SO4. Is this clear?
Sir, if you use sulfuric acid, then how would we get carbon dioxide?
No, see over here. See, we are adding the dilute acid. So it can be either sulfuric acid, nitric acid, or hydrochloric acid, right?
Yes.
So if it's a carbonate over here in Y, so when the acid reacts with this, isn't it, it is going to give you the carbon dioxide, the salt, and water.
Yes.
And now the salt has sulfate ions. And when we do this test and we have added barium nitrate to this, we will get the white precipitate.
Okay.
Okay. So it means that the sulfate ions comes from the acid, as they themselves told this. So that acid, if it comes from the acid, so acid must be sulfuric acid. Now, identify the cation in Y using the observations from test 3 and 4. So we have already identified that it's a zinc ion, right? Any confusion so far? Okay. Solution Z is colorless. The student thinks that it contains copper 2 positive ion. To state why the student is not correct. If you recall, the copper 2 positive ion has a blue solution, right? Forms blue solution. Now, part 2. Solution Z contains potassium ion. Describe how to do a flame test on solution Z to confirm that the identity of the cation. We have discussed earlier as well that first you are going to dip the wire into the solution. Then put it into the blue flame. Now, observe the color. And if you don't remember the color of the flame, you are going to get the color of the flame over here. It's a potassium, so the color is lilac. So mention over here that observe the color of flame, which must be lilac due to potassium. Is this clear to all of you? Now, solution that contains ions of group 7 element. Describe a test and the possible results to identify which group 7 ion present in it. So there are 3 group 7 ions: chloride, bromide, iodide, right? See over here, chloride, bromide, iodide. For all of them, you are going to add either dilute nitric acid, then you are going to add aqueous silver nitrate. So the precipitate color varies, and their color will help us to identify that whether it's chloride, bromide, or iodide. So you are going to right add aqueous nitric, sorry, dilute. We always use dilute acids. Dilute nitric acid and aqueous silver nitrate, and then Observe the color of precipitates which are going to be white for chloride or green for bromide or yellow for iodide. Is this understandable? Yes, any confusion so far?
No.
Okay. Now, question number 4, designing based. Argentine is an alloy containing only zinc, nickel, and copper. Zinc and nickel both react with dilute hydrochloric acid. Copper does not react with dilute hydrochloric acid. Plan an investigation to find the percentage by mass of copper in the powdered sample of Argentine. Your plan must include the use of a common laboratory apparatus, Argentine, and the dilute hydrochloric acid. No other chemicals should be used. So see, it's very easy that you have to mention the apparatus used. Okay. The method to use, the measurements to take, procedures to ensure that the percentage determined is accurate as possible, how the measurements are used to determine the percentage by mass of copper in the sample. So if you recall, you are going to use beaker with powdered, what is it? Argentine. Record its mass and then add dilute hydrochloric acid. So what is going to happen? Dilute hydrochloric acid is going to react with the zinc and nickel both, and we are left with the copper. So when the metal reacts with the acid, we will get salt and hydrogen gas. As the hydrogen gas forms, there is a bubbling. So when the bubbles stop, we get to know that there all the nickel and the zinc have been reacted. So as the bubbles stop, stop, remove the solid unreacted copper by filtration. Is this clear? Wash and dry copper with and record mass of copper for accuracy. Keep a wait until no bubbles form. Further, repeat and take the average mass. Till here, is this clear? Now, calculate the percentage of copper mass of copper divided by mass of argentine and then multiply by 100. So we will get the percentage mass by mass of copper. Is this clear to all of you? Okay, Miral, let me see. Which one? The zinc, the dissolving of zinc.
Yes.
Actually, you see, the zinc is not dissolved in acid. Actually, it has been reacted with the acid to form salt. It's not zinc aqueous. It is going to be zinc chloride or zinc nitrate or zinc sulfate.
But sir, the zinc is in excess.
So the excess zinc it won't dissolve, obviously, because it has been not reacted because all of the acid has been used up, so it stays solid. So you just separate it by filtration.
And sir, the solution would contain what?
Solution contains the zinc salt of the zinc. If you have used hydrochloric acid, then the solution contains zinc chloride and water. And if you use sulfuric acid, its solution contains zinc sulfate and water. And if you have used nitric acid, the solution contains zinc nitrate and water.
So the metal itself doesn't dissolve.
Yeah, metal itself doesn't dissolve in water. It always react. It turns into its compound, which are water soluble. So that's why it goes like this. So apparently it looks that it dissolves or disappears, but in actual it turns into another thing.
So sir, some of the zinc is turning into salt and some of it is solid.
No, actually it is not the case. I recall the question. That is the question of related to some other alloy which has a zinc and copper in it. And we have to know the percentage of mass loss, right?
Yes.
So when we add acid in it, the copper won't react, zinc reacts, so zinc reacts to form salt, and as apparently it seems to be dissolved, but actually it turns into aqueous salt, right?
Yes.
So we are not going to keep the zinc in excess because we have to make sure that all of the zinc is going to be dissolved. So we are going to add more and more acid, and will wait until no bubbles form. So it indicates that all of the zinc has been reacted and turning into a salt, and apparently all of the zinc is disappeared or dissolved.
Okay.
And when we filter the unreacted solid and we get its mass, so what we do, we have the initial mass and we have the unreacted solid mass. So when we subtract both the values, we will get the mass which is actually lost.
Sir, the undissolved solid would be copper and the dissolved one would be zinc.
The all the zinc would be dissolved and actually turned into its salt.
Okay.
Got it?
Yes.
Okay. Any other question?
No.
Okay. So tomorrow, inshallah, as you have a exam the day after tomorrow, so we are going to keep two classes tomorrow, inshallah. One at around 4 or 4:30. I think we will start at 4. And then the next class we are going to do at the same time, like 8 or 8:15. Okay.
Okay,
Okay,
sir.
sir.
Okay. So take care, everyone. See you tomorrow. Goodbye. Allah Hafiz.